Coming up on This Week in Radio Tech, hey, I was there when radio engineers started making the switch to audio over IP. Well, now, about 10 years later, TV stations are doing the same thing, making that switch to video over IP. It requires a lot more bandwidth, and there are a few technical challenges yet to be solved. Erling Hedkvist from Lawo is joining Chris Tobin and me on This Week in Radio Tech. Our show is brought to you by Direct Current Broadcast e-newsletter. Get Direct Current in your inbox every Thursday with technical pointers putting you and your facility at an advantage. And by Lawo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. Glad you're here. It's our 334th episode of the show. Man, we've been here a while. And we got a really unusual or interesting show today because it's even a little bit different than our title, This Week in Radio Tech. It's usually radio-centric, but stick around. I've got a surprise for you, but it's going to dovetail right into where we radio engineers are going. And you might want to just get on the phone, hit a quick chat, get your TV engineers friends to tune in right now as well, or download the show afterwards. Watch it on YouTube or at gfqnetwork.com. Or on my website, thisweekinradiotech.com. Lots of ways to get the show, but it's on Facebook Live right now and gfqlive.tv. So call a TV engineer friend. Get them to watch. They're going to like it. All right, our show is brought to you by a couple of great sponsors. We'll get to them in a minute. But Chris Tobin is with us, as usual, from an unusual location that he probably can't tell us about. Chris, where are you? What?
Sorry,
what is that?
It's a spinning color wheel. No, sorry, it's not. It's an 8-inch bullet for a transmission line.
That thing has got to cost a pretty penny.
Oh, it does, and the copper that goes along with it is even a few more pennies. Yeah, wow. I'm actually I'm at a FM site, actually a multi-tenant site. It's not only FM, so there's some other stuff here in New York City. And behind me is a balanced combiner from the Shively Labs folks. So it's, I think, let me see if I step away, maybe you can see a little more of the, there you go. Unfortunately, the darkness in the background is because the motion sensor turned off the lights, so I'll have to, during the break, change that out. But that's what's behind. So there are FM signals going through the combiner cavities.
I've got to ask a couple quick questions. So you've got a bunch of FM stations there, all combining into one feed for a master antenna, or maybe two feeds for a master antenna, right? Yes, you said it was a balanced combiner, and I've never understood what's the difference between a traditional or maybe an unbalanced combiner and a balanced combiner. Can you give us the elevator speech on it?
I have to look it up again to remind myself. I did research, and I totally forgot to get my notes together. But I'll find out the differences between them.
Okay. Because I've heard that. Yeah, I don't know what it is. I'm sure the answer, the non-tech answer is it's better that way.
I'm sure it is. I do know that the Shively combiners, the filter cavities that behind me, this white box, are mounted vertically so that the tuning assemblies and stuff do not detune because they're in a different position. A lot of times combiners are horizontal like this. The Shively's are this way. So gravity doesn't sort of affect the tuning of the box. That's how it was described to me on a couple of occasions. They run much cooler than some other traditional combiner technologies that are on the market.
Yeah, a lot of them have big heat sinks built on the combiner.
Oh, yeah.
Cavities.
There are heat sinks on here. I don't know if you can make it out. Probably not. There are small heat sinks, but it's a very, very efficient system. When all the FMs, this is a backup site for FMs. When all of the FMs are operating from here, it still runs pretty cool. And I think in a couple months we'll be doing a full-blown test for RFR purposes, so it should be fun. I'm going to be here to check that out.
Is there any TV at that site?
Yes, there is. Several DTVs here.
Okay.
Oh, it's a busy site. It's a very busy site. Those looking and watching who are familiar with this facility will look at it and go, wow, is that what it looks like on camera?
Well, Chris, you know that one of our sponsors on the show, and we've talked about them every week for a year and a half now, is Lawo. And Lawo, we've been advertising their audio over IP consoles for radio. And people know Lawo for great big consoles, often used with television and other big live broadcasting events. And their radio division has been a sponsor on the show. But we keep hearing about, at the various trade shows, we keep hearing about video, professional video in production environments. At some point, moving from the SDI routing environment into the Ethernet and video over IP environment. And we thought, hey, who could we get to tell us about this, just so radio engineers are better informed, and we'll get some TV engineers watching the show as well to kind of bring them up to speed. And lo and behold, it's a gentleman from Lawo, because Lawo has been getting into this business for quite a while now. So let's bring him in. Our guest is Erling Hedkvist. Hello, Erling. Glad you're here.
Hello. Thank you so much. Thanks for having me on the show, and thanks for not butchering my very complicated last name. So thank you.
I'm sure. Now, where did you grow up? Where's the name Hedkvist from?
Oh, the Hedkvist family. I'm surprised it's not globally known. No, it's the Kvists in general are Swedish. So you might know a couple of other Kvists in NHL, for example. You got the Lundqvists and the Nyqvists, and all the Kvists tend to be from Sweden, and so am I. So I'm originally from northern Sweden.
Okay. Hey, need to make sure you get introduced sometime to two Swedish friends. We have Leif Claesson, who does audio processing at Telos, and then our friend Kenneth Anderson, which is a stage name, but it's easy to say. He says it's easier to say than his real name. And I want to say he did a lot of radio in Malmo.
Okay. Cool.
I think that's right.
It's a major.
Okay.
That would be Malmo. Yeah, that's the southernmost of the large cities. So I would say that's it's a top five station call sign probably in Sweden if you're in Malmo for sure.
So you're a Swedish guy working with a German company, and you are on the west coast of the U.S. Welcome to the USA.
Thank you so much. I'm glad to be here.
So, a couple of years ago, I heard that Lawo was getting into video over IP, and that you had a good engineering staff already knowledgeable about this, but you've also brought some other people on board. And the purpose of this show is to help us in radio understand, video over IP, what's different about audio over IP in radio, and what are some of the challenges that you still face in implementing video over IP. And when you and I talked earlier today, you said something that was really kind of amazing, and that is that, Kirk, most video is already over IP. Tell me what you meant by that.
Yeah, so it's what we're talking about here is the last holdout of video moving to IP in the broadcast infrastructure. So you take any broadcaster, large or small, today, and I would bet that 75-80% of the signals inside their facility, or the media that is shuffled around inside their facility, is already on IP today. Let's take just some example. Take TV station here in Los Angeles, KT something, whatever, right? They're out doing news, sports, programming. Just look at their lineup, basically. Most of their lineup is already non-live, right? So it's being produced in a studio or out in the field, etc., in a non-live environment, captured on image, right? Disc. It's not captured on tape anymore. So it's captured in ones and zeros, transported, post-production, edited, etc., all done over basically data file transfer and IP. As it gets played out, so the eventual distribution from the TV station to, if it's over the air, if it's to a cable network or a satellite, if it's distributed over the internet, all that distribution is already happening over IP. If you are Fox and you need to distribute your main programming to 300-400 affiliates around the country, that is already today happening over IP. Might be over satellite, might be over fiber, but it's happening in packets. The only portion that is still in coax, that is still in a big iron video switcher in the basement, is the stuff that is truly live, for truly on air, such as sports and news. Everything else is already in packets. So that's what we're talking about. We're talking about changing this last holdout to also that be in fully IP.
Okay, this now makes a lot of sense. That explanation helps me a lot because in working with audio over IP for the last 12 years or so, I would, and it sounds like you're doing the same thing with video, I would explain to engineers, hey, your music is already stored digitally, and you're converting that into either AES audio or analog audio to route it over to an audio console to bring it into the audio console where it may get turned back into digital if it was an analog input for mixing, and then it's going to come out of the audio console, perhaps as analog, perhaps as AES, and the point there, and you may send it over an STL or streaming that is IP. The point there is we were doing a lot of conversions, and now that people have moved into an audio over IP world, it's quite possible that the same ones and zeros that represent a song on a hard drive are the same ones and zeros that show up to the, we'll say, the input of the audio processor for the radio station. If it's routed directly, now there may be a gain change in an audio console if that's being run live, but now this makes sense. So much of what video does is delivered to the broadcaster, to the TV station by an IP path, that being satellite now. Much, if not all of that, is IP now. And there may be other, of course, it's stored. The packets get stripped off, and the digit is stored on the hard drive server. So yeah, a lot of this the shuffling is already taking place in the IP world. We're just looking at TV broadcasters changing their infrastructure inside for live stuff. And I guess you're talking about what commonly SDI connections. Isn't that what's typically used these days?
Yeah, so we're talking about replacing the HDSDI, the coax connectors in the basement, and the term that we use and maybe some other vendors might use as well is what we call core infrastructure. So with core infrastructure, we talk about the heart of the facility, where things need to happen live, where things need to be guaranteed bandwidth, where things need to be guaranteed timeliness. If the news show starts at 6 p.m., it actually starts at 1800 frames. It doesn't start at 1822 frames. It starts exactly at that frame boundary, and to do that, you need technology that can time to that level, and that's what traditionally the coax, the core infrastructure is providing for these broadcasters, and that's what's now moving over to IP.
So I'm guessing that in the course of this conversation, you're going to be helping us to understand a bit more about some of the challenges in going to IP, because HDSDI, being a serial format, is naturally quite fast. I'm sure there are a little bit of delays here and there. That's how we end up getting lip sync issues from time to time between audio and video. But for the most part, it's tied pretty well together, and it's pretty instant. But when we switch to IP, we probably end up with a little bit more latency and maybe some frame boundaries that don't happen to be in the right places. So I'm guessing that's what we're going to talk about solving. Before we talk about solving that, though, I wonder if you could tell me what some of the benefits are. Why would a television broadcaster want to replace their core infrastructure and go to a video over IP infrastructure?
So now I'm going to sound like a politician and say, I'm glad you asked me that question. Because that's a really good question. It's a relevant question. Because really it comes down to why change? Like, this is working. So what if everything is around me is IP, and like what's the benefit? What's the benefit for me as a broadcaster? And I'm sure, just as it was with radio, there's a number of benefits, but let me highlight a couple for you that, at least in my view, I find customers find interesting. One is flexibility and utilization. Actually, do you use this term in radio, but do you call it transmission chains? Like with
yeah, we do. Sure, and typically we often mean, by the transmission chain, we often mean from the output of the audio console or the production switcher or the master control through whatever it has to go through and onto the transmitter. But in TV, maybe you mean even a larger chain than that.
No, we mean that, but also let's extend it a bit further to further into the production side, if you will. But let's examine that word. It's a transmission chain, right?
Mhm.
So it's links together to each other, right? So
Mhm.
traditionally, that's exactly how it was done. You take an output and you put one of the chains is a device, it's a function that does something to my content, right? It might add the closed captioning. It might be a GPI connector that checks if my adverts needs to be clicked on or off. It might be the emergency brake for if the president needs to go on air, right? All these are part of this chain, but it is a chain, and to change something in this chain, because they're hardwired in this case in coax, basically
Mhm.
we take an output and we connect it to this device, connect it to the other device, connect it to the other device, is very difficult. With IP, we could perceivably connect all these devices into an IP network, and we can loop them in on demand. So what we're talking about is basically the ability for higher utilization of resources.
Mhm.
They've done some
Mhm.
studies of how much in a production facility, how much of your equipment is actually being used at any one point of time, and it's somewhere around 10 to 20%.
Yeah.
80%. So 80% are all your capex, and presumably a certain amount of OPEX to drive that, whether it's being in operation or not, is bound into equipment that you're actually not using. Even
Mhm.
more to the point, you have this encoder, whatever. You bought 10 encoders last month, and your engineering guys were glad enough to put this into your transmission chain. And now you said, this project we got coming up, we got this new music show, and I'd like to put that on these new encoders I have. And they say, oh no, they're on these other transmission chains, and
Mhm.
we can't move them over. And you go, I just bought it. They're not being used. Yeah, but they're in the chain. It's like I have to take it out of the chain and put it into this other chain, and they don't have the. So that's a big part of it. The ability for IP to give us more ins and outputs in a networked environment, to be able to network our devices together in a way where I can just loop them in on demand, and thereby be able to monitor my utilization. And for all intents and purposes, it comes down to spend less money and utilize my equipment more. That will be one advantage that IP can bring you. The other advantage that we see a lot of people talk about is, of course, when we move into 4K. So
Ah.
the absolute largest uh, traditional video routers you can buy today are about 1,000 by 1,000 in one huge frame. Now, now 1,000 by 1,000 is enough inputs and output for most broadcasters, even the very large ones.
Mhm.
However, if you talk about 4K, this now immediately becomes a 256 by 256.
Oh.
Which is not enough, because they were talking 4 times the bandwidth for a 4K signal, at least. And that's not talking about things like high dynamic range or high frame rate or any of that fancy stuff that people also like to talk about, which perceivably gives even better video quality than the resolution itself does.
Yeah.
So if you are VP, senior VP, whatever, of broadcast engineering at your facility, and the CEO guy comes and says, "Okay, I need you to here's a bunch of money. Please expand the facility for the next 10 years, because I'm not intended to come back and give you more money, right? So you do it
Yeah,
for the next
right.
10 years, and build a solution, and then you have to go, okay, I can buy a HDSDI solution today, which we know it's ready, it's not a problem, etc. And we know how to do it, or I can buy an IP solution. The big issue is whether 4K is going to happen or not. If you think that in the next 10 years, the CEO of this station group or programmer might come to you and say, "Hey, we need to do some 4K here." If you think that might happen, you have no choice but to go down the path of IP, because you simply cannot solve this in a traditional broadcast environment. Someone's going to come back and say, "Yeah, you can do what you do, blah 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 blah." But okay, bear with me on that one. For 99% of the cases you can't solve it in over traditional infrastructure. You have to move to IP. It's the only thing that has the capacity to push this kind of traffic. Then you face with a choice, and that's why we're seeing a lot of people move towards IP solution, because they feel if their boss comes to them 5 years from now and say, "Hey Bob, you know the new Singing with the Stars show that we're just doing? We need to do that in 4K." And you go, "Oh yeah, about that. We installed this big iron systems. I can't do 4K. Is that a problem?" Yeah, you're kind of out of a job right there. So that I see is a big driver. People really want to move to IP, maybe even sooner than they are normally would be comfortable with, because they can see this big scepter on the horizon. Say, I need to be able to support 4K, and how do I do it? So I would say it's utilization, to be able to use your facility more efficiently, and it is future-proofness. Those are the big two drivers that we see at the moment.
Now, I'm going to make an assumption here, and Chris Tobin, maybe you can chime in and let me know if I'm on the right track here. My experience with audio routers was that they are they're designed for a small niche industry, as are video routers, and the traditional router, traditionally very reliable, very effective, but you build it for a certain size, and it's really not very expandable, or it costs you double or more to double the capacity of the router. In other words, it's not a technology that lends itself to expansion very far. The backplane's only so big. On the other hand, IP does lend itself in many ways, not every way, but in many ways, to expandability. So years ago, we did a project with Radio Free Europe, Radio Liberty in Prague, Czech Republic. And last I heard, they were, now this is audio, not video, it's audio, but they were up to 4,000 sources and about 1,700 destinations. So their router, I mean, technically it's balanced. They could do 4,000 in, 4,000 out, but it's IP. And so, that they needed that expandability to go up really huge. You can't go buy a traditional AES audio router that's 4,000 in by 1,700 out. So, Erling, are we looking at IP because it has this expandability that hardware designed to do a certain function maybe doesn't?
Yes, that's another reason. Again, 4K, for all intents and purposes, is more bandwidth, and more bandwidth means we need bigger switches or bigger switch planes, etc. And that's the same argument that you just brought up regarding this Radio Free Europe project. It's the same thing. And if you look at some of what's happening in the programming space, some people call it the long tail, or there's other words for it as well. But basically, you have this fractionalization. Is that a group? Is that a name? Sorry, but basically,
I don't know.
you have a lot more programming that's a lot more niche than you used to do. So. Yeah. Go back 20 years and look at the TV, and you had what was the 20 years ago the final of what was it called? MASH. It's called MASH, right? It was the
MASH. Sure.
People, yeah. MASH, yeah. 40 million people tuning into it. I think if you're really, really good today, you maybe get 6-7 million people watching a show, maybe 10 million people watching a show, but you have a lot more of this long tail. So if you are into cooking Asian food with Shinsu steak knives, there's a show for that.
There's a show for you, yes.
If you're into cooking with the other knife, there's a show for that too. So you have all this programming being made and this pushed out. So you have a lot more content on there to satisfy people's desire of, something that's very specific to me and my interests, etc. And in turn creates more programming that goes into bigger switches to produce all that.
Yeah, Chris Tobin, I bet you've seen the same thing even more in New York than we have in Nashville. But here in Nashville, the TV station where I used to do the weather, Fox 17, under one roof, they've got 4 TV stations, and at least 2 of those have additional HD channels that are programmed. Here in Nashville, one of the the CBS affiliate runs a full-time HD2 channel that it's full-time programming. A lot of it's locally produced. Then a lot of TV stations have a full-time weather channel that has a lot of local cut-ins with local information. So yeah, the amount of content is growing and growing and growing, and that's a lot of responsibility on a production facility. Chris?
Absolutely. I can tell you that I've worked at a couple of facilities where the HDTV over-the-air signal had multiple sub-channels, and in the back office, if you will, or in the infrastructure, the studio side of things, the amount of switching that was needed, all of that was over IP, and it wasn't a true IP switcher. I'll say that, a packet switcher. I'm not saying an Ethernet switch, but that was 5, 6, 7 years ago. We were doing that kind of stuff. And then during the time, the last couple of years, I worked with a friend of mine who's done some work with folks up at ESPN in Bristol. And they have recently, I think for D2, I think I got that right, D1, D2, they installed an IP switcher from another manufacturer, if memory serves me correct. And for the reason, as Erling pointed out, they're covering sports from everywhere. And they needed some way to bring things in and out. And the traditional methods were just no longer available, especially when they started doing, at the time I think it was 2K, and now it's the 4K thought. So yeah, audio over IP is seeing the same thing. We've just packaged it differently. I helped build a facility, as you know, in downtown Manhattan, where we had 2 core switches, and we were switching all kinds of packets around. And that was just for the office stuff. That was over 500 workstations and 6 different radio stations plus 15 different studios. And that was just the Ethernet switching alone. And then when we started doing audio switching, that was another set. And it grows fast. And we didn't have as much niche programming as some folks do today. But yes, if you're not thinking IP and you're not looking at that for both audio and video, you're definitely going to be in early retirement without choice of your own, because and the niche stuff is growing faster. I mean, I guess you could say in some respects it's OTT, over the top, is part of that niche thinking. And to get that stuff going and video on demand, if you're a broadcaster or a content creator or a content distribution network creator and you're doing stuff, you need to be thinking this. And then there's the outside broadcast element. You're a radio, your TV station, and now all of a sudden you're in a community that's a multinational community, and you need to do many things. Do you want to bring them always back to the studio, or do you want to be able to do it on site, on location, but bring it back in the form of IP Ethernet and integrate it and make it on its way out? So, yeah. I mean, folks at Lawo are in a great position right now. It's like the nexus of everything going on to be introducing this stuff. They have the experience of audio consoles and all necessary methods behind that. Now they just add a couple of pictures to it, and it's like, hey, here we go.
Well, there are some technical challenges, and Erling is going to tell us about those. And maybe he can't reveal everything that Lawo's doing about it, but they are working to get the last couple of challenges out of the way so that this video over IP switching can really be effective. And I just want to point out that, hey, 10 years ago, and it still happens today, in fact, when a radio station moves from a traditional infrastructure, audio, maybe in some kind of analog or digital router, or a digital infrastructure, AES, and doing the routing there, or maybe they have no router at all, as none of my stations ever did, and they put in an audio over IP system, all of a sudden you discover all these incredible things that you can do that you never could before. So especially remotely, you can handle a lot of stuff. And my own radio stations in Mississippi and in American Samoa are just terrific examples of the serendipity of going to a network-based infrastructure and then being able to do things that, oh my gosh, we can do that. I got a call last week. Can we put this programming on this station for the rest of the week? Yeah, we can do that. Why do you want to do that? Well, it's not important why I want to do that. Just let's do it. Okay. Let me know when you want to make the switch. And from here in my office, 300 miles away, I did that. And you're going to be able to do that kind of thing with video over IP as well, and have it be very, very flexible and quality, just wonderfully perfect. So our guest this week on This Week in Radio Tech is Erling Hedkvist, and he is with Lawo, and he's with their video solutions as they move into video over IP. Chris Tobin is along from a secret location in Manhattan where he's in front of a bunch of FM combiners. Man, woo. a lot of RF there when they turn all that on. I think you said that was a lot of backup stuff. So
yes, there's 2 FMs going through here right now.
Okay. Just two. But there could be a lot more. What is there, a total of 8, 10, 12?
I think it's 1, 2, 3, I think it's 12. I think it would be 12, yeah.
Gotcha.
It's very busy.
All right. Our show is brought to you in part by my friends, my employer at the Telos Alliance. And listen, you got to subscribe to this Direct Current e-newsletter. Here's a message about why.
Not much in the paper today, is there?
Not much. Seems tough to stay informed, you know?
Like we're missing out on stuff, important stuff.
Yeah, feels like week-old news. Yesterday's stories. Half the tech stuff in here seems out of date by the time I see it.
What Kirk doesn't know is I'm way ahead of everyone else around here. Every Thursday, I get this newsletter in my email. It's Direct Current. The folks at the Telos Alliance publish this.
What Joe doesn't know is I keep one step ahead of the radio guys in this market. Every Thursday, I get Direct Current from the folks at the Telos Alliance. It's a free newsletter about radio engineering, audio, streaming, studios, everything.
Thursday afternoons, we have our department head meeting. I look like a genius, thanks to the knowledge, updates, and advice in Direct Current. Sometimes I wonder if I should tell Kirk about Direct Current. Might help him out.
I wonder if I should let Joe in on my secret. He could use a little help sometimes.
Nah.
Get Direct Current in your inbox every Thursday. Read profiles of engineers and newsmakers in the broadcast community. Get technical pointers putting you and your facility at an advantage. Important industry news and views. Plus, you'll be up to date on Telos, Omnia, Axia, and Zipstream products. It's all here in the Direct Current newsletter. Subscribe online at telosalliance.com/directcurrent. That's telosalliance.com/directcurrent.
And we're back. It's Kirk Harnack along with Chris Tobin and our guest, Erling Hedkvist of Lawo on This Week in Radio Tech. And we're actually going beyond the radio tech because radio got in on the whole IP infrastructure thing before television did. And now, for a few years now, television has been talking about, hey, we're going to have to make the jump into IP. And it's a little bit complicated. So Chris Tobin's along. Chris, welcome back in that undisclosed location in Manhattan.
Thanks. Yeah, the video IP is something radio broadcasters need to start paying attention to if they want to be viable and relevant.
Indeed. So many radio stations are doing some video. A lot of it is kind of video on the cheap side, with lipstick cameras or just little pan tilt zoom cameras. Some of them are indeed, SDI connected, so they're going with the the current technology through a little video switcher.
Even if it's lipstick, webcam, regardless of what the mechanism is, it's the workflow. You need to develop the workflow. So if you're getting into it, the IP side of it, the Ethernet side of these video elements start to build. I was working with a friend of mine on a project, last year, and his station was doing, they were using webcams, and then they started realizing they could do more, and they went out and purchased actual cameras that have HDMI out into an HDMI USB adapter, which went USB 3 into the laptop, into the video switcher was in the laptop, and then IP streamed it right out to their CDN, and they started producing stuff, and now they've got up to 4 shows, 6 cameras, and they're starting to figure out how do they start switching stuff and doing things, because now they want to add more niche type programming. And it's a radio station.
And I think a lot of radio stations, here in Nashville, there are studios owned by Cumulus that are that have pan tilt zoom cameras and full video production capability. And I think you're just going to see more and more of that. One thing we ought to be really clear about, though, is we tend to mix our words for IP delivery, and there's delivery to your home of IP like YouTube or any kind of streaming video, Netflix, for example. This is all compressed. A lot of it's highly compressed, and a lot of it is automatic bit rate, right? So if if you're watching Netflix on a cell phone on a 4G connection, you're watching your movie at a lower bit rate than if you are at home on a fiber or good cable connection. You're going to automatically see it at a higher bit rate. Well, that kind of video over IP is not exactly what we're talking about here. What we're talking about is infrastructure, and that is typically within the bounds of a TV station or video production facility where you have a lot of different. You have studios, one or more studios. You have control rooms. You have production control rooms. You have video servers. And in a TV station, you'll have satellite receivers as well, bringing programs in. Or maybe you're getting video over Vivix or some other service like that. And the point there is, in this case, we may be talking about some slight compression, but we're also talking about either uncompressed or – but you know what? Before I make a mistake, let's ask Erling about that. Erling Hedkvist is our guest from Lawo as they're moving into video over IP solutions. So, Erling, help me understand about video that's flying around in a video over IP solution for infrastructure, replacing an HDSDI core system. Is this compressed in any way? What kind of bit rates are we talking about?
So what we're talking about is basically real time, and we're talking about high quality. So then when you break that down into what do you mean by real time and what do you mean by high quality, it depends is the answer. So in most cases, if we could just compare it to what you see today, real time means basically that we're in the milliseconds or microseconds space of delays and jitter that's far below that, and jitter meaning packet delay variation. So the difference, so the pace at which packets are being received to us. This is today. In existing infrastructure, bit rates of commonly 1.5 gigabits for normal HD, 3 gigabits for 1080 progressive, and upwards for 4K, etc. So those are kind of the bit rates and the timing delays that we're talking about at the existing core infrastructures that are around today.
Huh. Okay. So, I guess in the audio world, when we move infrastructure audio around in a system like Ravenna, Livewire, AES-67, all of that is completely uncompressed. It's linear audio, typically at a 24-bit depth and typically 48 kilohertz sampled. So it's really difficult to. I mean, you can't really get much better than that. So it's linear. But video bit rates are, especially when you're looking at 4K and 4K 60 frames per second. Oh my goodness, this could be an incredible bit rate. And I guess I'm still trying to understand it in my head. Is this maybe at the camera control unit? Is it reduced to something, or are we looking at linear bit rates from this? Can you answer that question?
Yeah, absolutely. So you're looking at 12 gigabits per second for 4K at 60 frames per second. Or higher when we talk about high dynamic range and wide color gamut. I'm not actually sure of how much more it is, but higher than 12 gigabits for sure. Now, the thing is that for today, everything is uncompressed. And also the way when we talk about 4K, people normally talk about uncompressed. But because 4K is such a huge jump up from 1.5 gig to 12 gig, there are people talking about what's called mezzanine or low latency compression methods. So there are systems out there, both from ourselves and from other vendors, that lightly compress video. So we're talking about compression ratios between 2:1 and 4:1. The most popular one being around 4:1, because it would basically make a 12 gig signal a 3 gig signal. And most broadcast infrastructures today are already wired for 3 gigs. So that would mean that they could do 4K already on their existing infrastructure. And that was that kind of the 1% I was talking about earlier. So there is always ways around moving to an all IP system, and you can make it work for a little bit, etc. And this would be kind of the initial method for someone who says, I can't afford to change my facility, but I need to go to 4K, tomorrow. They would basically throw bandwidth at the problem or throw compression at the problem. But there are discussions around what's called low latency compression methodologies, and there are a few different flavors of those as well, which I could probably spend half an hour talking about as well, which I probably shouldn't go into. But yeah, that's one way. Was one way of doing it. It was interesting what you mentioned earlier about the audio router. We just did a project in France last summer, the Euro, and we had an 18,000 by 18,000 audio matrix. All the commentary for all the Euro. Do you know what the size is of an 18,000 by 18,000 audio router in IP?
What? I don't know. What's
one rack unit.
What?
Yeah, because it's all low bit rate, or low from my world, 3 megabits per stream. I'm like, what? No big deal, right? So it was actually two. There was two rack units because we did it fully redundant. So it was two racks for the total of 18,000 by 18,000 audio. So yeah, it's amazing what you can do when you move to the capacity of IP.
Yeah, and IP capacity is just growing and growing and growing, and part of it is to meet this kind of need. It's just amazing where we are now compared to where we are even where we were 10 years ago, and especially 20 years ago. I was around when it was a big thing to go from a 10 megabit switch port to a 100 megabit switch port. That was a big thing in the mid 90s when we were doing that. And maybe you can spend just a little bit more time talking about this gentle compression that can be done to make some existing infrastructure work now. Is this purely a mathematical, or is it a I don't know the right word, psychovisual? In other words, usually when we talk about video compression, a lot of us are used to kind of bad video, and I don't think that's really what you're talking about here. You're talking about something that's pretty gentle, right?
Yeah. No, it is mathematical, and it is very basically it is extremely high quality. So there's a few different flavors of this. There is one method called TCO. It stands for tiny codec, and the tiny is meant to mean the amount of processing power it requires. So it's something that's cheap to implement in silicon. That's manufactured by a company out of Belgium, which name escapes me because I'm useless with names. But it's basically a good product, but it is their standard. So if you want to use it, you have to go and talk to them to buy it. Then we have LLVC, which is low latency video codec, and that's Sony's standard. So if you want to have their standard, you go and talk to them, and it basically does the same thing. It's a low latency, kind of cheap to implement. And the last flavor is Direct Pro or VC2, depends on. I think one is the profile and one is the name of the codec. Can't remember which one is which. It's basically invented by or started by BBC in the early 2000s, maybe something like that. The initial intent was to go from 1.5 gig HD down to SD at 270 megabits to be able to use HD on SD infrastructure, and that is an open standard, so anybody can develop that code and put that into their product. So it depends on which manufacturer you go to, what they will support. So you have VC2/Direct Pro, which is the open standard, and then TCO and LLVC, which are the closed standards. Let's put it that way.
Let's see if we could. We don't have a lot of time left. Let's talk about two things before the show gets over. One of them is, with audio, we don't have things like frame boundaries like we do with video, and I know frame boundaries can be a little challenging with video over IP unless you implement some new standards. And earlier today, you were telling me about an older standard, SMPTE 2022, and then there's some newer standards, SMPTE 2110. Can you just give us a little bit of an idea of what's the purpose of SMPTE 2110? What's that doing for video over IP?
Sure. So SMPTE 2022 has been around for a long time, and the original concept behind it was just to transport video over IP, i.e. just make IP a coax cable. That was the original intent. So the standard was defined very simplistically. SDI stands for Serial Digital Interface, right? So it's already ones and zeros, right? So the intent of SMPTE 2022 was just to take video as it comes to you, take the ones and zeros, pack them into IP packets and send them off. On the other side, unpack them, send them back into SDI, and off you go. And it works pretty fine. And people have been doing it for a very, very long time now. Lots of manufacturers, including ourselves, do SMPTE 2022. So that works if you want to send something from A to B, and it's pretty easy. Now, when you want to actually build an infrastructure, a core infrastructure to build something with this, you cannot replace a video router with a coax cable. You cannot replace a video switcher with a coax cable, because there is no, how do you connect things together? How do you splice things in and out? And that's basically what the SMPTE 2022 standard was. It's just a cable in itself. So what SMPTE 2110 is intended to fix is to do a couple of things. One, to make it clear when the start of frame is, so that the IP, if you investigate, if you look into the IP packets, you will see when a video frame starts. At the moment in SMPTE 2022, an IP packet might have a little bit of video in it, but also a little bit of data, whether it was embedded into that SDI stream, in embedded audio might also be in that. And maybe a little bit of the closed captioning is in there as well. You just don't know. You have no idea until you unpack it all and put it up on the raster, and then you can see what's going on. In 2110, the video is carried in one multicast stream and only the video, and we have put some start and end of frame mechanism in there as well. The audio is de-embedded from the encapsulated encapsulated audio in the SDI stream and sent on separate AES-67 streams. And lastly, the metadata, which is information such as AFD, closed captioning, time code, source ID, all sorts of stuff that people put into their metadata, is also traveling on a separate multicast stream. And all these streams together as a group create what used to be everything that existed in the SDI cable. And the purpose of this now is that once you put all this stuff over IP and it sits and it resides on an IP network, on an IP switch, I can selectively now route things differently or do things differently. I can take video now that I know this is a video essence, and I can go into that essence. I can do something with it because I know where this packet, I know what line that is. I don't have to unpack everything just to do a change in a video line, for example. I might just be able to take a few packets out, do something to them, and then put it back in again without unpacking everything. The audio is the same thing. I can route the audio differently. I can route the audio to different audio processing. I can do my audio embedding, switch muxing, etc. Everything can be done in the IP domain, and I can modulate the metadata to whatever I need to be before it gets packed together again as a stream. So that is the difference between SMPTE 2022, which is a very rough mechanism to just encapsulate SDI into IP, and the more granular method of 2110, when we know what is in each stream, and we call this element stream. So it's the element of the video that we take out the separate multicast streams.
So it sounds like with the element streams, with SMPTE 2110, you will reduce quite a bit the need for the de-embedding and the embedding process that happens, seems like, over and over every time you have to add a piece of equipment to the chain.
yes, hopefully we can completely remove it, so there will be no need whatsoever anymore, because on embedding, the embedding is just the ability to switch or route audio in a different way. So at the end of the day, the receive device, where you want to receive whatever video you have or whatever audio you want, would just subscribe to the video element that he wants and whatever audio elements or element that he requires, and that's the metadata that goes with it.
You use that word subscribe. Yeah, you use that word subscribe, and that's exactly what we do in audio over IP. You know, there we go. We probably learned from you. Yeah, well, the router. You're 10 years ahead of us anyway. Yeah, well, unlike a traditional router, the router's not really making switching. It's just responding to subscription requests. Hey, I want this stream. Sure, you can have that one. I'm going to take away the one I was sending you, but here's the new one. And that's with video, I guess you just have a few. Well, you have a lot more bandwidth, and then you have these considerations over the frame boundaries and things like that you've said as hopefully being addressed in SMPTE 2110. Hey, before we go to our last break, I want to mention that there's a group that Lawo is a part of, and so are a lot of other companies. It is the Alliance for IP Media Solutions, or AIMS. Their website is aimsalliance.org. We'll put a link to that in the show notes. The Alliance for IP Media Solutions, and they're adopting AES 67 as the audio standard, as you alluded to earlier. But these are big companies like AJA, Canon, CBS, Cisco, Ericsson, Evertz, Grass Valley, Harmonic, Imagine, which used to be Harris, Lawo, of course, NBC Universal, Telos Alliance, Riedel, Panasonic. You kind of get the idea here. Sony, Tektronix. All these companies are full alliance members. So I think with all these people working together, solutions will be forthcoming to make everything IP and everything working pretty well at some point. You share that optimism?
I do, and actually I take great pride in the fact that Lawo was one of the 4 founding members of AIMS. I really do believe that we are taking a leadership role in this space. And now with AIMS, I think and with SMPTE 2110. So AIMS was originally promoting what was called TWiRT and TWiRT4, which was kind of the draft standards, which now have been moved up to SMPTE. So this is what we see as the fruits of our labor now, is that this is moving through the SMPTE standardization process. So we're very excited about it.
Good deal. Chris, video over IP, man, it's the coming thing.
Who would have thought? I don't know. I was doing some that crazy stuff a couple of years ago. Who would have thought?
I know. We always ask Chris about something new. Oh, yeah, I did that. Yeah, I already done that.
You know what? That's, as a friend of mine I worked with many years, always said, he goes, when you're out there in the front of the pack, sometimes the arrow in the back is worth it. So I have a lot of arrows in my back from those pioneering days.
I remember the words of Steve Church, the founder of Telos, years ago, and he said someday. Now, he was talking about radio. So someday, microphones, headphones, satellite receivers, playout systems, audio consoles, they're all going to have an Ethernet jack on them. And sure enough, you can buy a Neumann microphone with an Ethernet jack now. You can buy speakers from Genelec that have an Ethernet jack on them, AES 67. And someday, maybe we're almost already there, every TV camera, TV satellite receiver, every piece of TV gear will just, we'll do away with the BNC connectors for HDSDI. It'll all just be Ethernet, and we know Ethernet connectors are cheap and they work. So I think that day is coming. It's coming. Hey, you're watching This Week in Radio Tech, and we're talking about television, video over IP. I'm Kirk Harnack, along with Chris Tobin, and our guest is Erling Hedkvist with Lawo, and he's with their video solutions. We're going to take a quick break and be right back with our tips of the week. Chris has got one, and Erling has one as well. I may have to come up with one here. Our show is brought to you in part by our friends at Lawo. If you know me, and I guess you do know me, you know that I've been a broadcast engineer and on-air guy, the host of this show. Now, what you may not know is that I've also been around the world selling broadcast equipment. That job took me country after country after country, and I've seen a lot of broadcasting in a lot of countries. And I've seen the different imaginative ways that people do things. It's fascinating. And that's one of the reasons why I'm excited to introduce you to our sponsor, Lawo, LAWO.com. Now, Lawo is famous around the world for television audio and video. That's what they started doing. That's what they've, the huge consoles at their NAB booth and IBC booth. That's what you see there. They do high-profile events. The production companies choose Lawo to do the Olympics, World Cup soccer, the Grammy Awards. So when the broadcast is mission critical, you're very likely to find Lawo there. Well, it's really overbuilt. It's over-engineered. It's redundant. Their backups have backups because there's just no do-overs in live event broadcasting. Dead air can kill your career. Now, hey, why should I care? I'm not doing TV. I'm doing radio, and so is most of you in our audience. Well, radio guys hate dead air more than TV guys do, which is why broadcasters like NPR, the BBC, CBC in Canada, to name a few, buy Lawo radio consoles. So when you're involved in TV and radio around the world, that means Lawo's also thinking a lot about the future. Everybody knows that all types of media are converging on IP delivery platforms. And Lawo is ready for that with broadcast gear that can handle audio, video, and control of every studio device using a single integrated commercial off-the-shelf computer network. And after that, well, there's virtualization coming along, broadcasting from the cloud. And imagine all your stuff being somewhere else. You just control it, kind of like you do now, but it's somewhere else. And Lawo's already building the tools to do that too. So if bulletproof reliability, 5 nines of uptime, and being future-proof are important to you, check out Lawo. And if you would, please go to the special website, the link just for TWiRT listeners, Lawo, LAWO.com/TWiRT, TWiRT, to find out more. And we get a little credit for that. They know that you're listening or watching when you go to Lawo.com/TWiRT. All right, quickly, we had got a couple of tips for you. And Erling, you suggested one offline that looks pretty promising. Why don't you tell us about this website?
Well, in all honesty, I found this one just about a month ago, and I was so impressed that I immediately, how we get too much stuff in our email, and I spend at least half an hour every day unsubscribing. Well, this is one I subscribe to, and I'm happily seeing I'm actually on the weekly updates and not just the monthly one. So it's called the Broadcast Bridge, and it's the broadcastbridge.com. It's a website out of the UK. I'm just reading now. It's actually a bunch of privately owned and operated business. You don't have to pay them anything to go in and read their articles or subscribe to their newsletter. They seem to be vendor independent. But what I find interesting is the fact that they take a special interest to this IP world, and they explain it in very good layman terms. So I was very impressed with their website and then their knowledge and their information, and I can just highly recommend it. It has nothing to do with Lawo or any other vendor that I know of. So I don't know how they make their living. I'm sure somehow, but highly recommend it.
Yeah, I'm not sure. It is the broadcastbridge.com, and oh my goodness, this is a good example of a company that is just full of giving you information to help you decide on what you need. Even if you, for example, I was just looking up teleprompters. If you don't know much about teleprompters, but you think, I need a teleprompter, they have articles in there about how to choose a teleprompter. So, and IP infrastructure is in there as well. Good tool here to use. Whether they have some advertising for a few of people that either they represent or they link to. Lawo's on there. Snell Advanced Media is on there as well, for example. And, well, good choice. Thebroadcastbridge.com. Chris Tobin, how about you? Got a tip for us in all that RF?
Oh, yeah. A real simple tip. Actually, the other night I was helping a friend of mine do a broadcast, and with all the cables on the floor, I realized, I said, you should really label those cables. So I'm going to remind everybody, whether in the studio, transmitter facility, or out on an outside broadcast, it's worth labeling cables, because he pulled out a plug thinking that it was one thing or another, and it turns out it was the camera cable, and he disconnected the camera. So we went to black. Audio continued, but we went to black. So it's simple, but remember, labeling is very important. And the other thing I wanted to show, if Suncast has it, everybody, I always get emails from time to time from people asking me, when you're on location, as I am today, how do you do it? How does it come across? Is it a simple setup, or is there a crew of people behind me or in front of me? There are none. That's my setup today. There it is. Okay, step stool
Wow.
holding the laptop, tripod with webcam, and the light is up on top of the frame, an empty frame where combiners will go. That's my light. And I had to blur out the stuff in the back because I just had to do that. But that's the setup. That's today's setup. Very straightforward, so it's not impossible. Just
Wow.
show it off.
Nice. That's a more complex setup than sometimes you and I have had. I feel ashamed now. I should bring more stuff when we do a show together.
Oh yeah, the rooftop overlooking the Empire State Building. That was a very ad hoc. Hold the light in front of me. Thank you very much.
Yeah. Here, would you hold this light for 20 minutes, please? Can you hold it for 20 more minutes? Oh goodness, yeah. And the time that we almost got kicked out of a hotel in Las Vegas last year.
Oh, that's right. Yes, I had a little scuffle with the security officer, or something like that. I'm not sure what he was. We managed to get through that though.
We'll have to figure out something for this year because we'll both be at NAB, I guess, on Thursday. Maybe.
Oh, yes.
I'll be there.
Yeah.
Okay. So
I'll be there.
all right. Well, come to think of it, didn't last year? Oh wait, just last year we did it from the booth at Telos, so that worked out. And you were at a booth across the hall.
I was with the Digigram folks. Yep.
Yeah,
it
was the Thursday prior during the Public Radio Engineering Conference.
That's right. Yes.
With the hotel and the security guard who had to, didn't like us.
Well, we were there for how long, and then all of a sudden, out of the blue, he just decided he's no longer liking that we were there. Doesn't make sense.
Good thing we weren't terrorists. We would have torn up the place already.
Exactly.
Erling Hedkvist with Lawo, thank you so much for being here on the show today. I appreciate you taking your time.
Thank you so much for having me. I appreciate it. Thanks.
It's been very helpful. We'll put a link to Erling's LinkedIn profile on the show notes. Thank you for joining us. Thanks to Suncast for switching our show and fixing problems, making that look good. Thanks also to Chris Tobin for coming to us from another secret location in New York City. Someday he's going to run out of secret locations, I think. Well, I hope you tell your friends. I hope you tell your friends about This Week in Radio Tech. And thanks for subscribing either to the audio or video, or hey, both. I subscribe on all my devices. That way the download count is higher. No, I don't really. I think 2. And appreciate Andrew Zarian for being the founder and running the GFQ network. We'll see you next week. I think Bob Heil's our guest on This Week in Radio Tech. Bye-bye, everybody.